I'm gonna go ahead and jump right in. All right, so just to give a really quick introduction, earthquakes pose a serious risk to infrastructure, economic viability, and human lives all across the world. And in significant occurrences, buildings could be knocked over, homes could be destroyed, families may end up displaced with their valuables ruined, and hundreds to thousands of lives could be lost all across the world. So as a result of the unpredictable nature of earthquakes, foretelling their impacts have proven to be difficult, especially pertaining to the death toll in each case. So in an attempt to pinpoint which qualities in earthquakes lead to the largest number of lives lost, the questions that we addressed in this report are how do magnitude, intensity, focal depth, and houses destroyed impact the number of deaths due to earthquakes? Does geography play a role in the number of deaths due to earthquakes? And then lastly, how have the number of deaths due to earthquakes changed over time? And then just to expand on that a little bit further, everything being equal, did more or less people die from similar earthquakes in the past compared to the present? So moving forward, determining where the strongest earthquakes occur and how the strength of an earthquake impacts human lives is crucial for many purposes. For the individual buying a house, knowing where these earthquakes are more prevalent is important in ensuring that they can live in a safe place where the risk of being impacted by an earthquake is minimized. If one does live in an area with a high prevalence of earthquakes, it is also critical to understand this so they can prepare for any possible earthquakes in the future. For insurance companies and other protection to avoid catastrophic loss is also important. So that they can know like whether or not they want to charge premiums for the solutions that they offer or not. So earthquakes, like this analysis definitely be important to individuals buying a house, as well as insurance companies looking to provide insurance to consumers. Research on the impact of earthquakes is fairly incomplete due to the fact that statistics for magnitude, death toll, destruction, and et cetera of earthquakes only recently became reliable. One prevalent research project performed by Cardiff University on magnitude and risk in 2017 analyzed the relationship between the magnitude of earthquakes and their associated death tolls. The project tested the hypothesis that larger magnitudes in natural disasters lead to higher fatalities. The researchers concluded that for any given magnitude, the number of fatalities ranges from 0 to a maximum number, while the maximum number of deaths tends to increase with magnitude for earthquakes near or below magnitude 7. That does not hold true past 7 on the Richter scale. Hence, Cardiff University study concluded that there is a weak positive correlation between an earthquake's magnitude and death toll, which is essentially where the basis for our report came from. Moving on. The data that we used for this report came from the Significant Earthquake Database, which was gathered by National Center for Environmental Information. And then just to give a little bit of background on this organization, it is a part of the National Oceanic and Atmospheric Administration of the United States government. This data was collected for public knowledge and reference. And then just to also give a little more background, the data set covered earthquakes occurring from 2150 BC to the present, though the data that is being used for the study only incorporates earthquakes that included data on all of the explanatory variables being tested, thus limiting the data set to only including earthquakes post 1877. And then moving forward to talk about the variables defined in the data set. So like on top of like the basics, date of the earthquake, location, name, longitude, and latitude. The data set also defined focal depth of the earthquake, magnitude, modified Mercalli intensity, deaths, injuries, damage in dollars, and numbers of houses destroyed. And all of those were variables that we took into consideration in thinking about how to analyze these earthquakes. And then also just to mention really briefly, since some of these earthquakes are missing certain variables, the set is filtered to only include earthquakes with complete data. The missing data is random throughout the data set, meaning there is no underlying cause for why some earthquakes are missing certain metrics. So for the analysis, the number of deaths is the response variable, while magnitude, modified Mercalli intensity, focal depth, the number of houses destroyed are the explanatory variables. All right, and so moving on to analysis of our regression. So to begin the regression analysis, a linear model was created with deaths as the response variable, and magnitude, MMI, intensity, houses destroyed, and focal depth as the predictor variables. The fitted values versus the residual values. And I have an entire appendix with all of our graphs that I will be referencing throughout the presentation. So I think I'm supposed to send this out afterwards, and feel free to like flip through it if that's helpful at all. But the fitted values versus the residual values were plotted for model number 1 to check its fit. And then kind of skipping past all of these like very detailed responses, just to mention some of the methodologies that we used. We used Cook's distance to check for outliers and get rid of extraneous points. We used the AIC method to check for the best model to use to analyze this data. We used data transformation just to give us a better look at the data. We used the histogram of residuals, the Durbin-Watson test, and then R-squared values and variance inflation factors to check for a bunch of different things, like whether or not the residuals were correlated. And happy to go into more detail about all of that, and it's also all in our report. But I'm going to just skip past that, as that's probably the more boring part of this presentation. And then just to touch on a discussion of our analysis really quickly before I begin to wrap up. And then here are the questions that we addressed again, and just to read them over one more time. Like, how does magnitude, intensity, focal depth, and houses destroyed impact the number of deaths due to earthquakes? Does geography play a role in the number of deaths due to earthquakes? And how have the number of deaths due to earthquakes changed over time? The number of deaths was able to be predicted from earthquake magnitude, intensity, and number of houses destroyed through the formula listed above in Figure 5. It was concluded that focal depth was not strong enough, was not a strong enough predictor to be included in the model, thus leaving the model to only include those first 3 predictors. And the number of deaths due to earthquake was not able to be predicted based upon geography. Although the data includes the location of where these earthquakes occurred, the technology that would have been necessary to graph these points across the map was unavailable. Given this sophisticated technology, it would have been possible to at least come to a general conclusion on this question. And then lastly, regarding the last question, the lack of adequate statistical and technical knowledge prevented a firm conclusion from being reached. However, through the research that has been conducted through this analysis and contextual intuition, a reasonable hypothesis is that the number of deaths due to earthquakes of similar magnitude has likely decreased over time. The main factor behind this is founded upon improved house building technology and regulations, and et cetera. Obviously, different countries have different building regulations and codes, but building regulation has improved over time as structural technology has improved. So just to recap our conclusion really quickly, earthquakes have devastated countries all over the world for centuries and will continue to have large impacts on society in the future. And although this analysis helps discern what factors affect the number of deaths due to earthquakes, much of the solution to this is out of society's control beyond improving housing structures. So hopefully, with improvements to both the protection methods against earthquakes, the technology to measure their impacts, and analysis of earthquakes impacts like this will improve. These improvements and increased regulation of building codes will continue to decrease the impact caused by earthquakes, not only causing less damage to property and society, but saving lives all across the world as well. So I'm gonna stop it there and just say thank you for allowing me the opportunity to even present here. It's been a wild week of classes before Thanksgiving break is coming up soon. So I'm gonna unshare my screen. Happy to take any questions offline, but thank you very much, and I'll pass it on to the next participant.